My name is Gunlavoina Shiva. My roll number 4H5. Today my topic testing methodology for STT RAM spin transfer torque magnetic random access memory. Abstract. We proposed a novel self-reference sensing scheme for spin transformer torque random access memory STT RAM to overcome the large bit-to-bit variations of magnetic tunneling function MTJ resistance different from all the exciting schemes. Our solution is non-destructive. The stored value in the STT RAM cell does not need to be overwritten by a reference value, and hence long write-back operations of the original stored value is eliminated. The robustness analysis of the exciting scheme and our proposed node destructive scheme are also presented. The measurement results from a 16 kb testing SEEP successfully confirmed the effectiveness of our technique. Testing STT RAM spin transformer TACU magnetic random access memory device is a critical process to ensure their reliability, functionality, and adherence to specifications. This memory technology utilizes magnetic operators and data storage, making it important to thoroughly validate its performance. Below is a delayed testing methodology of STD RAM along with explanation for each step. Pre-test preparation, device characterization. Before testing, it's essential to understand the basic characteristics of the STT RAM devices, including their size, materials, and expected performance parameters. Test environment setup. Ensure that the test environment is controlled for temperature, humidity, and electromagnetic interference (EMI) to minimize external variables that would affect test results. Test equipments calibrations. Calibrate all testing equipments to maintain measurements accuracy throughout the testing process. Power on self test post a basic functionality check. Verify that the STT RAM device power up correctly, initializing properly, and responds to basic read and write operations. Error detections and corrections. Implements error detections and corrections mechanisms to identify and correct bit errors during read and write operations. Performance testing. Read and write speed. Measure the read and write speeds of the STT RAM device under variations operating conditions, including different temperatures and supply voltages. And endurance testing. Perform endurance testing to determine the number of write and erase cycles the device can withstand before degradations occur. This helps establish the device expected lifetime. Retention testing. Assess data retention capabilities by storing data in the device for extended periods and checking for data loss. Functional testing. Read and write functionality. Verify that the device correctly reads and writes data according to the specified interface and protocol standards. Example of SPI to Vlsi. Data integrity. Test data integrity by comparing read data to the originality retained data and ensuring they match. Reliability test. Temperature recycling. Subject the device to temperature recycling test to assess its performance and reliability under different temperature conditions. Shock and vibration testing. Elevate the device's resistance to shock and vibration to ensure it can withstand environmental stresses. High humidity testing. Test the device's performance under high humidity conditions to assess its resistance to moisture related issues. Power Consumptions testing measure the device power consumption under variation operating conditions to ensure it meets specified power requirements. Security testing perform security testing to assess the device's vulnerability to physical and software based attacks such as side channel attacks or data tampering. Compliance testing ensure that the STT RAM device complies with industry standard and specification such as JEDEC to guarantee interoperability and compatibility with other components. Documentations and reporting document all test procedure results and any issues encountered during testing. Create a detailed test report that includes performance data, reliability assessments, and any deviations for expected behavior. Post test analysis analyze the test results to identify any areas for improvement or optimizations in the STT RAM design or manufacturing process. Continuation monitoring and post market testing after deployment. Ongoing monitoring of devices in real world scenarios helps detect and addresses any long term reliability issue, ensuring sustainable performance. This testing methodology is essential to ensure the quality, reliability, and security of STT RAM devices. Is variation applications including data storage, computing, and embedded system. It helps manufacturers and user assess the device suitability and compliance with industry standards. Regular updates and refinements to the methodology and essential to keep pace with evolving technology and security requirements. Thank you. Abstract. We proposed a novel self-reference sensing scheme for spin transfer torque random access memory STT RAM to overcome the large bit-to-bit variation of magnetic tunneling junction MTJ resistance. Different from all the exciting schemes, our solution is non-destructive. The stored value in the STT RAM cell does not need to be overwritten by a reference value, and hence long write back operation of the original stored value is eliminated. The robustness analysis of the exciting scheme and our proposed non-destructive scheme are also presented. The measurement results for a 16 kb testing chip successfully confirmed the effectiveness of our technique